Hi, welcome back to the course Data Science by RouteFabric, and today let us look at probability. In this video, we will be looking at different probability concepts that we will be using in our machine learning models. First, let us know what a random variable is. A variable x is a random variable if the value that it assumes corresponding to the outcome of an experiment is a chance or random event. A random variable is a numerical valued function defined over a sample space. Usually to denote a random variable, a capital letter is used and a corresponding lowercase letter is used to denote the possible value they may assume. For example, let random value variable x be the number of heads observed when we toss two coins. The sample space S is equal to heads heads, heads tail, and tails head, and tails tails. The random variable x is equal to 0, 1, 2, which is 0 heads, 1 head, and 2 heads. Now let us look at the types of random variables. There is discrete random variable, which is a discrete random variable is a quantitative random variable that has a countable set of distinct possible values. For example, we can say the defective toys in a shop of 20 and the number of students in a class and any whole number can be described as a discrete random variable. Whereas a continuous random variable is also a quantitative random variable but can take a countless number of values in a line of intervals. For example, this can be a weight of human. It can be 100 kgs or 200 pounds or 200.5 pounds or any value. Usually for continuous random variables, decimal numbers are used. Now let us look at what a probability distribution looks like. A probability distribution is an assignment of probabilities to specific value of random variables or to a range of values of the random variable which satisfies the following two conditions. The first condition is that the probability of each possible values should be between 0 and 1. And the sum of all probabilities should add up to be 1. As we talked in the data analysis video about mean and median, we identified mean and median to be the center of the data distribution and standard deviation and interquartile range as the measure of spread of the data distribution. To find the median of random variable, knowing its probability distribution, we use the expected value. The expected value of random variable is the sum of x times probability of x. To find the standard deviation of a random variable, that is, x is a discrete random variable with probability distribution, then the standard deviation of x is given by square root of the sum of x minus the expected mean of a random variable squared times the probability of x. Now let us look at what a probability density function is. In probability theory, a probability density function or density of continuous random variable is a function whose value at any given sample is the sample space that can be interpreted as providing a relative likelihood that the value of the random variable would equal that sample. The probability that a continuous random variable takes a value in a given interval is equal to the integral of the probability density function over that interval, which is in turn is equal to the area under the region of the xy plane bounded by x-axis. To find the value of the probability density function, all we need to do is take the integral under the curve from the two intervals, which is from a to b. As shown in the image, we will be taking the integral of probability between a and b to get the probability density function. Now let us look at normal distribution. Normal distribution is probably one of the most important probability distribution in statistics because it fits many naturally occurring phenomena. It is also known as the Gaussian distribution or the bell curve. The normal distribution is a probability function that describes how the values of a variable are distributed. It is a symmetric distribution, which means that there are mostly no outliers, and the center peak is where most of the data occurs. And farther from the center, the probability of values to occur in the far reaches or the edges is extremely unlikely. The parameters of a normal distribution are mean and standard deviation, mean deciding the center of the normal distribution and standard deviation deciding how the normal distribution is spread out. Now let us see how mean affects a normal distribution. Mean, as we know, is the central tendency of a distribution. If the mean is increased, the center of the normal distribution shifts towards the right. If the mean is decreased, the normal distribution is going to shift to the left. Now let us see how standard deviation impacts normal distribution. As we know, standard deviation is a measure of variability. It defines the width of the normal distribution. If the standard deviation is increased, the peak of the normal distribution comes down. In other words, if the standard deviation is increased, the width inside the normal distribution increases. If the standard deviation is decreased, the width inside the normal distribution is shrunk and it goes up. Now let us look at some of the properties of normal distribution. Normal distributions are symmetric. If it's not symmetric, it's not a normal distribution. In a normal distribution, the mean, median, and mode are all equal. Half of the population is always less than the mean and half is greater than the mean because the mean is the center of the normal distribution. The empirical rule allows us to determine the proportion of values that fall within certain distance from the mean. From the center of the mean, if we go one standard deviation towards the right or the left, we have 68% of the data. If we go 2 standard deviations from the center to the right and to the left, we will have 95% of the data. If we go 3 standard deviations to the left or to the right, we will have 99.7% of the data lying in this range. Marginal probability is a type of probability where the probability of an event to occur is not impacted on the outcome of any other variable to occur. To find marginal probability, all you got to do is add all the probabilities of the event A, then divide them by all the events. Now let us look at what joint probability is. Joint probability is a statistical measure that calculates the likelihood of 2 events occurring together at the same point in time, which is probability of A and B. Now let us look at confusion matrix. Confusion matrix is a table with 4 different combinations of predictions and actual values. Using a confusion matrix, you can get the recall, precision, specificity, and accuracy of your model. The key things in a confusion matrix are true positive, false negative, and true negative. True positive are those values which are correctly predicted by the model. False positive are the values that the model has predicted wrong. False negatives are the values that the model thinks are correct, but they are incorrectly predicted. True negatives are wrong both in the dataset as well as the model's prediction. Now, let us look at what is recall. Recall tells us how many of the actual positive cases we were able to predict correctly with our model. Recall is a useful metric in case where false negatives trump false positive. The formula for recall is that true positive divided by true positive plus false negative. Precision helps us know how many of the correctly predicted cases actually turned out to be positive. Precision is a really useful metric in case where false positive is a high occurrence than false negative. The formula for precision is true positive divided by true positive plus false positive. Next, we have something called F1 score. F1 score is a combination of precision and recall. It gives us a combined idea about how these two metrics are. It is maximum when precision is equal to recall. The interpretation of F1 score is actually kind of hard, as we are not sure if recall is high or precision is high when we find the F1 score. Lastly, we have accuracy. Accuracy helps us know how accurate our model is in predicting our data. If the accuracy is under 50%, which is a random guess between 2 labels or 2 categories or 2 events in the data, then the data is most likely corrupted or there is something wrong in the calculation of the accuracy. A formula for accuracy is true positive plus true negative divided by true positive plus false positive plus true negative plus false negative. I hope this was informative. To learn more about data science, please visit routefabric.com. Thank you and have a nice day.